Today we are going to talk about graphing our quadratic functions, this time using standard form. Standard form is the form that we've used over and over again, that ax squared plus bx plus c. That's our standard form. You're going to take your notes in your booklet on page 4. So let's start again by taking a look at what our x squared means. When we see that x squared, just like in the vertex form, it is a quadratic function and the graph is going to be a parabola. Now notice this time we don't have A, H, and K. We have A, B, and C. And this changes things just a little bit. I cannot look at this function here and determine my vertex right away. I have a little bit of math I have to do first. The value of A, however, does still have the same effect. If A is negative, if A is less than 0, it's going to be flipped. It's going to open down. If the absolute value of A is greater than 1, then it's going to be stretched or skinny. And if it's less than 1, it's going to be compressed or fat. This time to find the vertex, we can't just find H and K because it's not there. What we have to do is find our x coordinate by using x equals negative b over 2a. This is also how we find the axis of symmetry, by the way. Now to find the y value, we plug in. And to graph, what we're going to do is find the vertex and use a table of values, always with the vertex in the center. Remember, when we're graphing a quadratic equation, quadratic function, we want to be able to see that vertex and we want to see a few points on either side. So determining your vertex first is extremely important. Okay, let's look at an example where we are graphing. It says determine the vertex of the function, create a table of values, then graph. So the first thing I'm going to do is finding that vertex. I need to decide what my a, b, and c are. So remember, the a is in front of your x squared, the b is in front of your x, and the c is your constant. So to find our vertex, we're going to do negative b over 2a. So in this case, I'm going to have negative 4 over 2 times negative 1, which is negative 4 over negative 2, which is a positive 2. Now remember, to find my y value, I'm going to plug in 2. So in this case, because it's labeled as g of x, I'm going to do g of 2, negative 2 squared plus 4 times 2 minus 3. Notice this negative's on the outside, it's not getting squared. So negative 4 plus 8 minus 3, which is going to give us 1. So for my table of values, I am going to put 2, 1 right in the middle. I'm going to go down to 0 and negative, no, I'm not. Let's try that again. I'm going to go down to 1 and then 0, and then up to 3 and 4. So my vertex is right in the center. I subtract 1, 2 minus 1 is 1, subtract 1 again, and then I go on the other side, add 1. That puts my vertex in the middle and gives me 2 points on either side. I am going to choose to plug in 0, just because 0 makes it super easy. I get 0 plus 0 minus 3, which is negative 3. And then plugging in 1. Again, be careful with that negative. It's on the outside, so it's not getting squared. So I get negative 1 plus 4 minus 3, which is 0. And then I'm going to use my symmetry to fill in the other side. That way I don't have to do all that plugging in. Plotting my points, 0, negative 3, 1, 0, 2, 1, 3, 0, and 4, negative 3. Connecting in that nice, smooth, U-shaped curve, extending through and drawing my arrows. Now this graph may look familiar. If you look at your table of values here, and we go back to our notes on page 3, these graphs are the same, and I did that on purpose. I wanted you to see that a graph can be given in vertex form, and a graph can be given in standard form. And even though the graphs look different, we can get the exact same graph. And that's just if you simplify the vertex form, if you multiply it out and combine your like terms, you'll get it into your standard form. So again, to graph our quadratic equations in standard form, determine your a, b, and c, use x equals negative b over 2a to find your vertex, the x coordinate, plug in to find the y coordinate, and then do your table of values.